Hello everyone. In this video we're going to be starting our new unit on right angle trigonometry. Shorter word for the word trigonometry. We're going to use lots. Sometimes we'll just say trig. And all the triangles that we're going to be using in this unit are going to have a 90 degree. That's what a right angle means. So right angle means going to have 90 degree. The orientation of it doesn't matter. It could be upside down, kind of however they got it. Just as long as it has the 90 degree in it. Okay, so let's get started. First thing we're going to look at is the tangent ratio and a definition. So definition here for trigonometry is the study of the relationships between the sides and angles of triangles. And in the word trigonometry, trigon means triangle and metry means measurement. So all really trigonometry is triangle measurement. We're just finding sides, finding angles. So next what we're going to do is we're going to do this investigate. So we're going to try to come up with a conclusion for these different ratios that we're going to be getting. So in the first one we are going to have BC over AC. So BC means from the point B to the point C. So that would be from here, point B, to the point C, and that is 3. And then from A to C, that is here, all the way over to C, so that is 4. Okay, so that one I got 3 over 4. The next one we have is DE over AE. So I'm going to go from D to E, that's right here, so that was 6. And then from A to E, that is this right here, that is 8. Okay, and then whenever we have a fraction, what we should do is we should always reduce it. So I could divide the top by 2 and the bottom by 2. So I'm going to get 3 over 4. Okay, and then the last one we have here is FG over AG. So from F to G, that is right here. And then A to G, that is this really long one. And that is also right here. It's 12 at the bottom. So F to G again was right there. So we got 9 over A to G, which was 12. And then again, we always want to simplify our fractions. So this one I can divide both by 3. And I'm going to get 3 over 4. So what happened? What do we notice? We got 3 over 4 for this one. The second one we had 3 over 4. And the first one we had 3 over 4. So all of these we're getting the exact same ratio or exact same fraction for all of them. So our conclusion from this, it doesn't really matter the size of the triangle as long as we are using the one side that is across from the angle and the one side that is near the angle. Okay, all of those we got 3 over 4. So our conclusion, let's write it out. The ratios are the same for the triangles with the same angles. Okay, so in all of these triangles, this little triangle, this big triangle, and then the biggest triangle, all of those, we got the exact same ratio in all of them. Okay, so it didn't matter the size. So the tangent ratio is what we're actually going to get from this now. So we're going to kind of compare the triangle that we had up top with this new one down here. In all of those, we were looking from this angle here, and we went to this far side, and then we also went to the bottom side there. Okay, and we're going to come up with some names for those. So down here, we're going to be looking from that angle. Now that symbol we got there, you might have seen or heard of that before. That is theta. And all theta is, it's a Greek letter that stands for an angle. Okay, now what we're going to do is we are going to name the sides around this triangle. Now from Pythagorean theorem, you probably know what this longest side here is called. That is called the hypotenuse. The side that we're going to go all the way across to the other end there, picture this was like a, say, a weird kind of field. It's in this triangular shape, but if you were standing here in this corner, so let's draw a little guy there. If you were standing there in this corner and then your friend was standing way over at the other side, you might describe it by saying he's at the opposite end of the field. Same thing with a triangle. We call this the opposite side. And then this side that is quite close down here, that is what we are going to call the adjacent side. Okay, and the word adjacent, all that means is nearby. Okay, you probably heard that term used before when you're looking for some location and someone says, well, it's actually right beside this other store and it's adjacent to that one. So adjacent just means beside. So there are the names of our sides. So again, just to run through, hypotenuse, it's the side opposite the right angle. So here's the right angle, it's opposite, or it's just the longest side. Opposite is the side across from the acute angle being considered. So by the word being considered, we mean wherever you're standing from, you're on the other side of it, that's the opposite. If I was standing up here, then this would then be the opposite side. Okay? And then the last term, adjacent, that just means nearby or beside. So it's the one that is nearby the angle that you were standing from, but it's not the hypotenuse, right? Because if I was here, this one is nearby, and this one is nearby, but whichever one is not the hypotenuse, which is this one, that is the adjacent side. Okay, so now that we know these terms, we're going to use these terms to come up with how we got these ratios. Okay, and this ratio of this one side over here and this nearby side here, that is called the tangent ratio. So I'm just going to write on our triangle the sides that we had. This was opposite, all of these were opposite, and then all of these bottom ones were adjacent. Okay, and we noticed in all of those that we got the exact same measurement or exact same ratio in all of them. So the tangent ratio, let's just write it here at the bottom. So tangent of some angle, theta, which normally we just write tan theta for short, tan theta, that is equal to the opposite divided by the adjacent. Okay, so if you took the opposite side and you divide it by the adjacent side, that ratio, that fraction, is what we call the tan ratio. Okay, and again, this theta, it just stands for an angle. Okay, so now we're going to actually get into doing some examples. So in the first one here, it says calculate each trigonometric ratio, and we got tan of L and tan of M. So in the first one, we're going to be standing at L, that's our angle. So pretend we are standing from here. Okay, and then we're going to label our sides. So tan, I know, is opposite over adjacent. So if I was in this corner, going way over to the other side, that is opposite. And then the adjacent is the nearby side, but not the hypotenuse. So it might help to write which one's the hypotenuse. That's this really long side. So that means that this side has to be adjacent. So here's opposite, here's adjacent, it's just 5 over 12. Okay, and then always check to see if you can simplify your fraction. In this case, we can't. Okay, then we're going to do tan of M. So now I'm going to be at the M angle, so I'm going to erase everything on my triangle. Okay, so now we're standing here, and we're going to label our sides. Now the hypotenuse hasn't changed. Hypotenuse is always the longest side, but the opposite and the adjacent have now switched. Because if I'm in this corner going all the way to the other side, that is now opposite, and then this really close side, that is adjacent. So our ratio again, it was opposite over adjacent. So opposite is 12, and then adjacent is 5. So we got 12 over 5. And then that's our answer for that one. Okay, question number 2, it says solve for x. So we have to find either the missing sides, or in the last one, we got to find the missing angle. Okay, so we're standing at this angle right here in the first one, so put our little guy. I'm going to label my sides. This is the hypotenuse. This is on the far opposite side, so that leaves this one to be the adjacent. And we're going to start with a ratio. So tan theta is opposite over adjacent. I'm just going to use O over A. And then I'm going to fill in what I know. So I had tan, remember theta just means angle, and the angle is 40 degrees. So I put in 40 degrees equals the opposite is x, that was right here. Opposite is x, so opposite is x. And then the adjacent is 5. So adjacent was 5, adjacent is 5. Okay, and then now I have an equation that I just try to solve. So I gotta try to get this x by itself. Currently it's being divided by 5, so I gotta multiply by 5. And I gotta do that on both sides to keep it balanced. 5 divided by 5 here is gonna cancel. And so then I just have the x on the right side. And on the other side, I got 5 times tan of 40 degrees. Okay, and then this I'm going to put into my calculator, and I'm going to show you how we're going to do that. Okay, so pull up my calculator and turn it on. And then what we got to do, because we're using degrees here, the angle is measured in degrees, we have to go into mode and change it down here, radian and degree, we want it in degree. So go over and then click enter, and then it'll highlight it. That'll tell you that it is now in degree mode. Okay, and then you can just click clear to get out of that. Okay, and then I'm just going to type this in. So 5 times tan button is right there, tan of 40 degrees, and then close my bracket and click enter. Okay, so that's my answer. Now note, I don't actually have to have the multiplication symbol in between there. If I do this again, the calculator knows that I'm going to be multiplying in between, so I don't have to actually put the multiply, and I get the same answer. So let's write down that answer. X equals 4.1995. Okay, and then we're going to round this to the nearest tenth. It didn't say, but that's what we're going to round this one to. I'm just going to move this stuff up. Okay, so we got x equals 4 point, and there's the nearest tenth. The 9 is going to round it up, so we get 4.2. And our units, if we look up top here, they were measured in centimeters. So it's 4.2 centimeters. Okay, next we're going to look at question B. Just going to move my calculator out of the way. So in B, we're going to start by labeling your angle. Always label your angle first. Then put our little guy. This is the longest side, so that's the hypotenuse. If I look all the way to the other side, that's on the opposite end, so that's opposite. And then this one has to be adjacent. Okay, so start with a ratio. And then we're going to fill in the ratio. So tan of theta, theta was 62 degrees. Opposite was 21 meters. And then adjacent we had was x. Okay, and now with this one, I'm going to show you guys a trick. Whenever you have x here in the bottom, what you can do is you can switch tan 62 with x. Okay, and mathematically that will still be correct. I'll show you a quick little example. If you had 3 is equal to 6 over 2. Okay, so 6 divided by 2 is definitely 3. Now let's see if I change these, whether I'm going to get something that's still correct. Okay, so I changed the 2 and the 3. Now 6 divided by 3, that does equal 2. So this is still correct. So I can switch those bottom two. There's other ways you can show this too, but you guys can just know this little trick, okay, and it'll work every time. Okay, so I switch those. I'm going to have 21 divided by tan of 62 degrees. We'll get back out our calculator and we'll put that in. So 21 divided by tan 62 degrees. Close our bracket. And we get 11.1658. Okay, and then we're going to round this to the nearest tenth again. So that's 11.1658. that 6 is going to round up the 1. So we're going to get 11.2. And that was meters in this one. Meters right there. Okay, on to the last one. Now they got this x in an angle, so I'm going to label the angle, put my little guy, and then I'm going to label my stuff. So this is the longest side, hypotenuse. It's also across from the 90. Across from the angle, we call that one opposite side, and then this is the adjacent side. So let's start with our ratio, tan theta equals O over A, and then I'm going to fill everything in. So tan of the angle is just x, so now I got to put an x in here, and then opposite was 15, and adjacent was 18. Now this question is a bit of a different style than these previous two, because here we're finding an angle. Now we want to get this angle, or this x, by itself, so we got to somehow get rid of this tan here. The only way to get rid of a tan is to do the opposite, or the inverse of tan. So to get rid of this tan, I have to take what's called tan inverse, because then the tan inverse and the tan will cancel. It's kind of like if you times by 2, the opposite would be divide by 2. So if I had a tan, the opposite of tan is tan inverse. Okay, and then I got to do the same on the other side. So I'm going to take tan inverse of the other side. Okay, so these two canceled out, so there's just an x left. And then on the other side, we got tan inverse of 15 over 18. Okay, and then I'll put that into my calculator. I'll show you how we can do that. So the tan inverse button is this blue one right here. To get to blue, I got to click second, tan, then I'll put in tan inverse, and then I just put in 15 divide by 18, and make sure you close your bracket. So I got 39.80. Okay, now this was an angle, and our angles, we said, were going to be measured in degrees. So this is going to be 39.8 degrees. Again, here we just rounded to the nearest tenth. Usually though, for angles, you're going to most likely always round to the nearest whole, but in this case it didn't say, so we just rounded to the nearest tenth. Okay, the next question, it says a ladder leaning against the wall forms an angle of 63 degrees with the ground. How far up the wall will the ladder reach if the foot of the ladder is 2 meters from the wall? Round your answer to the nearest tenth. So with a question like this, a word problem like this, and we're not given a picture, first thing you should do is draw a picture. Doesn't have to be anything fancy, just draw a right triangle, put your 90-degree in there. Okay, so this vertical part here, this is the wall, and then my ladder is tipped over leaning against the wall. And then this bottom, this is the ground. So rereading the first sentence, it said a ladder leaning against a wall forms an angle of 63 degrees with the ground. So it was the ladder and the ground. Okay, and if I kind of highlight those two pieces, we said this was the ladder and then this was the ground. Wherever those two touch or come together, that's where the angle needs to be. So 63 degrees goes there. And then it asked how far up the wall will the ladder reach if the foot of the ladder is 2 meters from the wall. So we pushed the ladder 2 meters from the wall so that it was tipped over. So this is going to be 2 meters. And we want to find how far up. So that is going to be right there, and we can just call that x. Now that I got my picture drawn, I can start to go through and solve. So we're going to label our angle here. We're standing there. Far side is the opposite side. This is the longest side, or the hypotenuse. And then this close side here, that's adjacent. Okay, so start with our tan ratio. Tan theta is opposite over adjacent. Then we're going to fill it in. Tan of the angle was 63 degrees. Opposite was x. Adjacent was 2. Okay, and then we got to multiply by 2 to get rid of that divide by 2. So do this on both sides. 2's cancel out. And then I just have x on one side, and on the other side I got 2 times tan of 63. Okay, and then this one we're going to get, I'm just going to switch the sides. When we put in 2 times tan 63 in our calculator, you get 3.9252, and then some other decimals. Okay, and then we're going to round this to the nearest tenth it told us. So x is going to equal 3 point, we want that one. 2 is not going to round up, so we get 3.9, and then our units, those were meters. On to the next question. So in number 4, it says a radio transmission tower is to be supported by a guy wire. So I know I'm going to have a tower, so I'm just going to draw a quick little picture. We got the ground, I'm going to have my tower going up, and this is going to be supported by a guy wire. So I'm going to attach a wire onto the top of the tower and go to the ground. So it says the wire reaches up 30 meters up the tower and is attached to the ground at a horizontal distance of 14 meters from the base. So let's look at that first part of the sentence. The wire reaches up 30 meters and is attached to that tower point. So it's reached up 30 meters and that's where it attaches. So this side is 30 meters. And then it also said it is attached to the ground a horizontal distance. Horizontal is left and right. Horizontal distance of 14 meters from the base of the tower. So if I was at the base of the tower, I'm going to go a horizontal distance over, and that's 14 meters. And then it asks us what angle does the guy wire form with the ground. So again, it was guy wire with ground. So guy wire is this, ground is this, and then wherever those two meet, that is where your angle is. So we are trying to find that angle right there. We call it theta. So start with our ratio. Tan theta is opposite over adjacent. Then we fill it in. So tan of theta, opposite. We're going to have to label this on our triangle. So again, we're standing here, looking all the way to the other side here. That's opposite. This is a 90 degree in the corner there. So that makes this side, which is the longest, the hypotenuse. And then this bottom side, that is the adjacent. Okay, so opposite is 30 meters. And adjacent is 14. Okay, and you don't actually have to simplify this fraction. You can just leave it like that. Our calculator will do the work when we plug it in. Okay, but we do have to get rid of that tan theta right there. And the opposite of tan was tan inverse. So we take tan inverse and do it on the other side. Tan inverse of that. And tan inverse will cancel. So then I just have theta coming down. And on the other side, we got tan inverse of 30 over 14. Okay, and then plug that into my calculator. And when I do that, I'm going to get 64.9831. Okay, and then with this one, it said round to the nearest degree. So we are going to get 60, this 9 is going to round up to 4, so we get 65 degrees. So that's our answer right there. Okay, now this last question says problem of the day. We'll read it out first and then I'll give you a hint, and if you want to pause it and try to work it out before I go through it, you could do that. So it says a pipe mine called the Panda Pipe has northern and southern gates. A communication tower stands 100 meters outside the north gate. The tower can be seen from a point 300 meters east of the south gate at Camp A, so that is right here. The distance between Camp A and Camp B is 600 meters, so that's from here to here. It says calculate the diameter of the Panda Pipe. So we want to find, and we got to know what diameter is. Diameter is all the way across a circle. So we want to find this distance right here. So let's just put a marker on there so we know what we're finding. Okay, so we're finding from the one point all the way to the other point. Okay, and then we're missing some angles that are supposed to be on here. This should be 90. and this should be 90. They look like 90s, but they should be marked as 90 degrees. Okay, so what we want to do, we got to start with where we're kind of given some information and then work towards finding this diameter here. So what I want to do, because the only angle that I'm given is this one right here, I want to start from there and then kind of work towards this way, find something over here, and then use that to help find this distance. Okay, so looking at this triangle right here, we are standing at this angle, so right here, and I'm going to label my sides. So this is the longest side, that's hypotenuse. This nearby side is adjacent, and then all the way over to the other side, that is the opposite. Okay, so if I use the tan ratio, I'm going to be able to find this opposite side using the adjacent and the angle. So let's do that here first. So tan theta, opposite over adjacent, and then let's fill it in. Tan of 40 degrees is the opposite. I don't know. I'm just going to call it x, and then the adjacent was 600. Okay, so solve this, multiply on both sides by 600. 600s cancel, and I get x is equal to, and we could put this in our calculator, 600 times tan of 40, that is going to give us 503.4597, and then some other decimals. So I'm just going to put dot, dot, dot. Okay, now this number that we just got, we don't want to round it. I want to use that whole number so that I don't make a rounding mistake early and then at the end my answer is slightly off. So always round at the very, very end. Okay, so I now know this side. Okay, so I have another right triangle here, and I know this side, and I also know this side. And what I would like to know, I want to know this, but that's only a part of it. Okay, I know this is 100, so I could find, if I found this whole thing, I could just take away 100, and then I would know this piece. So I want to try to find this side. And whenever you got three sides on a right triangle that you're going to be using, that is just going to be using Pythagorean theorem. So let's do that just up over here. So this is like our second step. So a squared plus b squared equals c squared. That's Pythagorean theorem. And the c squared is the hypotenuse of the triangle. So in this case, the hypotenuse was this side right here. Okay, and we just found that was this. So that needs to be 503.45. I'm just going to put dot, 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 squared. The a and the b, it doesn't matter which one is which. So I'm going to make this side the a, and then I'll make this entire side the b. So I got 300 squared plus b squared. Okay, so to solve that, we got to get rid of that 300 squared. So let's minus 300 squared from both sides. Those will cancel, and I get b squared is equal to 503.45 dot, dot, dot squared minus 300 squared. And then the last thing we got to do is get rid of the square. To get rid of that square, we need to take square root. So square and square root cancel. I also got to do the exact same on the other side. Okay, and when I put all of this into my calculator, I am going to get 404.3163 dot, dot, dot. Okay, and now the last thing that I have to do, I now know that this b over here, let's write it, it's about that 404 number. Okay, that is this whole distance. So if I had that whole distance and then I took away this 100 meter distance, take that away, that would give me the rest of this, which is what I want. Okay, so the pipe diameter is going to be that 404 number, and I'm just going to subtract off the 100. And that is going to give us 304.45 33163. Okay, and it didn't say what to round to, but for this we're going to round to the nearest whole. So we get 304 meters. And that is our final answer. Okay, so that's it for questions. Our textbook questions, I'm just going to write here at the bottom. So we are looking at page 107 today. And we got these numbers.